here with another question from our hashing series. This is the question which is a little bit upgraded one from the question that we solved previously. The question is intersection of two arrays, second version. And the question says we are given with two integer arrays, nums1 and nums2, written an array of their intersection. Each element in the array must appear as many times as it shows in both the arrays, and you may return the result in any order. Now, moving on to the example part, this is the array that we are given, and this is another array. So, as you can see, we have two elements in common, that is 2. And we have to return all the elements which are common in both the array. No matter if duplicates arrive, we have to return the duplicates as well. This is the twist in this question. In the question that we solved previously, we were not supposed to return the duplicates. Now let's visually analyze what's happening in the problem to solve it further. So yeah, step 1, we need to count nums1. Count nums1 in the sense we need to calculate the frequency of the elements that are present in nums1. Where's my pointer? Okay. So we will have to use a HashMap. So in the HashMap, we'll be storing the elements mapped to the frequency. And in the second step, we traverse nums2. First of all, we'll go with the first element, that is 2, and the frequency of 2 is 2. So we add this element, that is 2, into our result and decrease the frequency by 1 from the hash map. So now this becomes 1. Then we move on to the second element of nums2, that is this, and the frequency now is 1, and we have to add this 2 to our result, and we need to decrease the frequency, which turns out to be 0, and then we have to return the result. This is the problem. So from our dry run, we understand that we'll need a hash map and an array list. Array list, why? Because we don't know what will be the size of the array that we are gonna return, right? So it's better to use a array list which will be converted into array later. Let's try to code this out. This is the algorithm that we have. First of all, we will have to store the frequency of nums1 in the hash map. Let's start coding. First of all, we'll create a empty hash map. Hash map. We'll need two elements, that is key and value. Both are of the same type, that is integer, comma integer. We'll name it as map equal to new hash map yeah, we have to store the frequency. Now to store the frequency, we will have to traverse through nums1, int n nums1, and then map dot put n comma map dot get or default, then put n comma 0 plus 1. Now for those who don't know how this function works, let's divide it into parts. Map.put, in the sense, as we know, we have to put two values into the map. So this will be one of the value and the other value will be this function will be calculating the frequency. How does it do that? That is using a function called getOrDefault. What does this function do? See, there are two parameters that are inside this function. One is the number that we are traversing and the other is 0. 0 because see, initially if that element is not present in our hash map, then the frequency will be 0, right? So default value of any number, the frequency will be 0. If it's already present in the hash map, then for that frequency we must add +1. I hope the picture is clear. If you don't get it, rewind the video and watch this again. Next, we'll be moving on to the second step, which is traverse nums2. Let's do it. For int n nums2. Okay. Now, what should we do after traversing? That is check whether its frequency is greater than 0 or not. So first of all, before checking the frequency is greater, first of all we have to check if that element is present in the map. Yeah, right? So if map dot contains key, this function basically helps us identify if the key that we are searching for is present in the map. So after that we need to check if the frequency is greater than 0 or not. Map dot get, yeah, this will give us the value is greater than 0. Then what should we do? Then we have to add it into the result. Only if both the conditions are true, then we have to add it to the result. Then decrease the frequency. So to add it to our result, we'll need an array. Let's just declare it. We'll name it as result. Is equal to new array list. Okay. Now we'll add this element into our array list. Result dot add n. Then we need to put the decreased frequency. We have to decrease the frequency of the element in our map. So map dot put n comma map dot get. This is how we are going to get the value, which is the frequency. Get n minus 1. I hope you guys understood this step. Why are we decrementing? Then what should we do? Then we have to convert the result, that is the array list that we have, into a simple array. Firstly, we need to create an array. Let's name it res new int of our result dot size. So of course result array lists size will be same as our results size. That is basic logic. And then we'll need an element for index, which we'll declare to be 0. And then we traverse through our result array list like this result. then is plus plus, we will store our I. Oh, this will overlap, right? We need to change the name of the variable. Keep it as en because both can't be I. Will get an error. Yeah, now we are done. It's the time to return our result. Okay, let's test our solution. Wow, test case is passed. Okay guys, now it's time to move on to the complexity part. So the time complexity of our problem is big O of n plus m. Since here n and m are the size of our array list. N may be the size of nums1, m may be the size of nums2. So we are traversing both of these array once. So the time complexity is value. And then we move on to space complexity. The frequency map may store all the elements of nums1, excluding the written result array. So the space complexity becomes big O of n. That's all for today, guys. Thank you for watching this video. Please hit the like button and subscribe for more such videos.